So what we're going to do in this session is talk a little bit about how we've applied the technology in Agile Requirements Designer around model-based testing to our own CA internal development across some of the other teams that I run. So I'm the VP of Software Engineering for the Continuous Delivery Business Unit. I run the Service Virtualization, Test Data Management, Agile Requirements Designer, and Continuous Delivery Director engineering teams. So what we've done is we've been trying to apply the model-based testing capabilities of ARD across some of my other teams, across Service Virtualization and TDM, and what I'm going to take you through in this session is some of our experiences doing that and some of our learnings. A little bit about why we wanted to do some experiments, what challenges we were facing that we thought model-based testing might help us with, what our hypotheses were, and what our results were. So what were our challenges and aspirations? The first one was around acceptance testing for new stories. So we've got agile development going on, stories are coming through, but you've got very compressed periods to do acceptance testing. You've got a 2-week sprint. So the question is, how do you do good acceptance testing in that kind of time constraint? So what we were finding is that when you look at downstream, the escape defects or other sources of rework in the system, and you triage that back to what the ultimate root cause was, often root causes in incomplete or ambiguous requirements, things that just weren't well enough understood up front. So one of the objectives we thought we would be able to address here would be trying to get clear about the requirements, higher confidence that the acceptance testing we were doing in the sprint was actually functionally covering the requirement, and that we understood what that even meant, and avoid those defects escaping later into the system and causing us either rework or just or other forms of pain if those defects actually get out to our customers. The other area was regression testing. So where you've got entire components and maybe you've got a regression suite of some of my products, it's 4,500, 5,000 test cases that you have across a regression suite. In the face of increasing rate of change, how do you maintain those test suites? Very difficult. How do we accelerate the extent to which we can automate those test suites, but also manage the maintenance problem associated with that? How do I understand impact of change and get efficiencies into that? So the number of problems we have both within new story development in sprints and regression testing. And we figured that model-based testing could help us with the acceptance testing problems in helping us to get to clear, complete, unambiguous requirements, confidence in the functional coverage, and fewer defects escaping the sprint. That's what we were hoping we would see. From a regression testing point of view, increased effectiveness and efficiency, less over-testing, less under-testing, more clarity about what we were actually testing and why, and then ease of maintenance and reduction to our automation cost, lifetime cost of automation. So I'm going to take you through 3 examples of where we applied the model-based testing techniques to try this out. So this comes from the SV team, the dev test product, which is being demonstrated on the floor. Many of you are familiar with this product. What you're seeing here is just one of the screens in there. It's a few fields, a couple of drop-downs, a multi-select checkbox. It's a panel, it's a bit of UI. So we wanted to say, for the functionality around that, how would we model that? And so we did it, and this is what the model looks like. It's pretty simple. Each one of the fields on the form pretty much maps to a node on this graph. And every path through the graph is essentially a test case. So all the different permutations of combinations of inputs to the different fields and what the expected result should be was modeled in this graph. And from that, we can tell that for that functionality that we modeled, there were 23 distinct paths through that functionality. And so if we were to run all 23 of those, we would functionally cover the requirement as modeled. Now, this is a relatively simple example. So within the Agile Requirements Designer tool, what the tool will show us, here are the 23 paths. I've selected one of them here. This happens to be path 15 of the 23. And it's showing me graphically on the model what that path looks like. And on the right-hand side, it's a little little small to read, but that's the English readout of what that path actually is. That's a manually human executable test case. Now, then the other interesting thing we can do is we can start to associate automation logic with each of the nodes of the graph. And when we do that, we're able to actually export from the model automated scripts. So we don't just export the test case, we can actually use the tool to create an automated script. So we decided to try that out, in this case generating protractor scripts mapping to those paths through the model. And the nice thing about this is once you've done this, if you can think about coming back in and making changes to its functionality, and the maintenance of the automated script library becomes much, much easier if I change the model and regenerate my scripts, as opposed to having to figure out, which scripts do I need to go edit. So we wanted to try that out and see what our experience with. And later on, I'll come back to some of the pluses and minuses and the learnings out of trying to do that. Quickly about how we automate the automation. So I've just zoomed in here on one of the parts of the graph. And if we just look at one of those nodes, in this case select port was one of the inputs on the form I showed you. What we have here is a number of each of the outputs from the node, each of the paths you can take after selecting the port, the different inputs essentially to that port field are modeled here as actions which map down to automation script actions such as clicking a button. And each action is also parameterized with variables that flow through the graph. So depending on which path you took through the graph to get to here, we'll get different substitution in those parameters. And then when you export that path, what ARD calls the automation layer, it essentially assembles an automatable test script. So that's how it works. So I'll come back to some of the pluses and minuses and the learnings from that simple example at the end. The second example we tried it with, again from Dev Test Portal, this is what looks like on the surface of it a simpler form. Just 4 fields here, and it's an embedded a panel within a larger UI. It's a widget really. And we wanted to try this one out. So modeling this one, again, the first thing we did was to build a very simple model, much like the first example I showed you. And this describes the basic functionality of that UI. However, in this case, there was specifically some UI behavior that we also wanted to test for, where actually, if you saw on the original, on the screenshot, some of those fields are grayed out. And there's logic there about certain things should only be possible if other things have already been set. So there's order and events, and it's a slightly more complex requirement to actually properly test. Now, this gets us into a gray area about where does unit testing stop and where does functional testing start, and in terms of testing against the requirement versus testing the actual implementation in the code. For us, this was gray area. We wanted to do an experiment with it, see how it went. So we took this model down a level of complexity and modeled that the order precedence issue, and it created a much more complicated model that looks like this. The experience doing that was it took a little while to get our testers that we were having use the tool thinking correctly about how to model that. It wasn't trivial. There was a bit of a learning curve to get over there. But what we found is that a few things came out of it. A couple are on the slide and one that was unsuspected for us that I didn't put on the slide, but I'll tell you about. The unexpected one was that this sub-dialogue is actually used in 3 different places in DevTest, on 3 different dialogues. And when we were having a conversation with the product owners or business analysts in your world about the requirement, there was disagreement. We were looking at the model and people were saying, well, no, it doesn't work like that, it works like this, because he was thinking about how it is in this part of the product. Other developers were saying, no, it works like this. It surfaced the fact that we'd been inconsistent in how we'd implemented this across the product, surfaced that, decided how it should be, modeled it that way, and then we were able to spin up a very small remediation issue, just dealt with a usability consistency issue, complete byproduct of what we were trying to do, but interesting. The proof of the pudding on this one, though, for me, is, okay, this is generating some tests. How effective are those tests? How good are they? How fit for purpose? Are they adding value to my world? So the 2 things that were interesting out of this one was when this story was done, we tracked what happens after the implementation. After the implementation of this story, a couple of sprints went by, it got into a release and got shipped. It's now been out for several months as part of the GA product for service virtualization. We had no escape defects either before we shipped or since around the functionality that we implemented here, 0. And I wish I could say that for every other story we've ever implemented, but between you and I, just quietly, I can't. Okay? So that's a good proof point. The other proof point that was interesting is that in the not the next sprint, 2 sprints after we did this, somebody actually tried to check in a piece of code that broke this. And these tests detected that immediately on the post-PR, the merge CI build. As soon as they did the check-in, kicked off a build, these tests found the regression immediately and flagged it. So the tests were useful, they did their job. Very important. So we found with this one that even though it's kind of going into the gray area of maybe modeling things a little bit more granularly than we would necessarily feel compelled to do, there was real value out of having done that. The third example is a much more complicated one, and this is where we get to the sort of the title slide of about the massive reductions in time. But before I tell you about how we modeled this, I need to tell you what it is, because this is a little bit of a complicated bit of functionality. This is in our test data management product. We have a capability we call TDM Shredder. Some of you will be familiar with it. What it does is it takes flat files on any non-relational format, JSON, XML files, and it will take them in, analyze them, and create a relational database-based representation of those files so that we can work with it in the tooling within test data management. And then on the tail end, when we're done with that and we generate data or we do whatever we do in the TDM product, it will take care of the reverse translation to get it back into JSON or XML or VSAM or files or whatever it is you want to work with. So it just kind of sits before and after TDM in a workflow. So just to talk it through real quick, in the case of an XML document, what I do here is I can register an XSD that says this is the schema of my XML, or if I don't have one, I just register the XML and it uses Venetian blinds to figure out the schema. It creates a set of tables in a staging database that relationally represent the structure of the data. It registers those tables with the test data management product. It imports the data from the sample XML into those staging database. And at this point, we're ready to start working with it in our test data management product. So there's a few things here that are not part of the shredder functionality in the light blue on the slide, which we do in test data management. Don't need to worry about that for the purpose of today. And then on the tail end, when you're finished with that, we have a reverse translation that says, take the data out of those staging databases that you published with TDM and put it back into XML. And the end-to-end is, I took an example XML and using test data management, I created many, many, many XMLs that are suitable for test data management needs that adhere to the same schema of the sample XML. Make sense? So this is a much more harder thing to model the functionality of, has some very different characteristics to the UI examples I talked about earlier on. In terms of size and complexity, just to give you a sense, this component is about 130,000 lines of code. And its complexity from a test point of view isn't so much in the flow, but is in the actual data inputs, all the different types of XML files and JSON files and their different versions and all the way in which you have to handle that based upon which versions of specifications you're using. So there's a lot of complexity actually in the files that you have to drive this with rather than the actual test case itself. So it leads itself more to data-driven testing than the UI functional testing we talked about earlier. So we built a model for that. This model was an awful lot more complicated. Unlike the examples earlier, which had less than 10 nodes on them, this model has 85 nodes in total. It's one main flow, which I've put on the chart there. There's 6 subflows, 2 of them are on there. Don't read them, it's just a sense of, this is a lot more complicated. This took a bit longer to do. Anybody want to guess how long it took us to model that? Shout it out. 2 weeks. Any advance on 2 weeks? You're a guru, so maybe 2 hours is possible in your world, but no, somewhere between 2 weeks and 2 hours. It actually took us a day and a half of sitting down and actually modeling this out to create this. What's that? Yeah, I know. We're just amateurs. Obviously, we're not as advanced as you are, Mary. So, okay. So a little bit double clicking into that model. One of the things that the Agile Requirements Designer tool has is this ability to use the concept of decision tables, which enables me to say, instead of having to model out all the hundreds of different types of XMLs or JSONs I want to push into this thing, I can get that into a single node. There's a few, like 5 or 6 different basic classifications of things, whether they're XMLs or request response pairs or WSDLs, whatever it may be. But I can drive it all from a table that's behind a single node. And when the tool exports all the test cases, it will flatten this out. So I'll get one test case for every line item of the data table behind that node, not just of the node. Now, that, as you can imagine, drives an awful lot of different test cases that can come out of this model. Even though the model's fairly complex, the number of test cases you can get out of this in total is really quite high. Would anybody like to guess how many test cases we generate from this model? Could shout it out, because I'll need to repeat. 500. How much? 10,000. Any others? Any other guesses? The right answer is 17,000. So it took us a day and a half to model functionality that generates 17,000 test cases that fully model the functionality. We'll come back to that in a sec. So this decision model is a very, very efficient way to model test case data. So netting it out then, by the numbers. So when we did this manually, the reason why I chose this component specifically was because it was something we'd relatively recently built, which means we knew the functionality very well. We had the engineers who wrote every piece of the functionality. This is not true for many older applications, and I'll come back to that in a sec. We chose this example specifically because it had that characteristic. And when we did it manually before we used the modeling, we created 318 test cases, not 17,000, 318. It took 40 man days to create them. The code coverage of those 318 test cases was about 55%. And my team said that they had 65% code functional coverage. But I think they're full of, because they have no freaking idea what the functional coverage was. They were guessing. With the model-based testing, using the ideas I just talked about, it took us 3 days to create the model. Actually, a day and a half of that was most of it. We spent the other part of the 3 days was doing some experiments with automation I'll come on to in a minute. The code coverage was 63% out of the 450 test cases that we actually chose to run to measure the code coverage. Obviously, we didn't go and run 17,000 test cases. So what you have to do is get smart about which tests am I going to run with a reasonable amount of capacity to get the biggest bang for the buck. So the nice thing about the Agile Requirements Designer tool is it has algorithms in there to help you subsect from the graph which paths give you the most coverage for the least amount of tests. And we chose an algorithm that gave us roughly the same sort of number of tests that we'd created manually, so we'd have a compare. So we selected 450. Those 450 gave us 63%. Had we taken the time to run 17,000 test cases, we would have had 100% functional coverage of what we modeled and built. So the takeaway for that is that the model-based testing allowed us to create just plain a better regression suite with a lot less time and effort, and more importantly, or as importantly, we know what the functional coverage is. Not only is, I can tell you what it is, and it's not a guess. And we know what we're choosing to not test and why. So then coming to the automation side of this, so we thought it might be interesting to try to apply that sort of, actually put the automation scripts in, like I showed you in the first example, in this example. We knew we weren't going to do it for this example across this whole model. So what we did is we selected one highly complex path, a path that went through, of the 85 nodes in the model, went through 43 of them, so a really long, complicated one. It took us 6 man days to get the automation into the model that would enable us to export that path and have it actually run properly in the automation. Okay. What happened then was, as we tried to do the next few, you start getting an incremental, the marginal cost of doing each one becomes cheaper and cheaper because you start building up node code within the model that you're going to reuse and reuse as you do additional paths. So what we found is it took us another 3 man days to do the next 13. And when we project that if we continued with this, we would get to a full automation of that in a similar amount of time as it took us to actually do the automation that we actually did prior to this exercise where we automated the 68. So there's a lot of work involved in getting the test automation done, but a huge amount of benefit potential there shown as well. But for us, I think the most important thing about this was around the functional coverage and the insight to the functional coverage and knowing what we were testing, what we weren't. So key learnings out of all this. Number one, actually the most compelling benefit for us, and this was so surprising because going in, we actually thought the regression testing case that I just talked about would be the most compelling one. The one that was actually most compelling for us was what we got out of it in terms of requirements, clarity, and those discussions, the collaborative work between the developers, the test engineers, and the product owners within our Agile teams, getting clear about what the requirement actually was. And then using that to generate those acceptance tests for the story. I think it's on the build here, yeah. So I have a QA engineer in my team. His name's Robert Eagleston. He's been doing QA for donkey's years. And I asked him about the before and after of using ARD in the process inside the Agile team versus not. And my question to him was basically this. If you look at this in terms of your confidence level that you as a QA engineer have, that when you say, yes, I'm done with my testing, and I'm happy to say, yes, this story is done. It meets its acceptance criteria, it meets its done criteria. My confidence level that when I say that, there are not going to be problems with this that are found later on in pre-release testing or regression testing or found by customers after we ship it. What's your confidence level that you've actually not only got 0 defects in this thing, but your testing really was first class? And he said before he used ARD, it was a 3 out of 10. Why? Because he didn't have high confidence that the requirement was fully correctly specified, and he didn't have enough time really to do full functional coverage test case design in the confines of an Agile sprint. So, you're cutting some corners. Combination of those effects said, realistically, I had a 3 out of 10 level of confidence. Once we brought ARD into the model, into the process, not just the actual test case modeling, but the combination of the test case modeling and the requirements modeling and the collaborative discussions that went on between the PO and the developers and the testers during the modeling brought up that confidence to what he called a 9 out of 10, which in his words was because I never give anything a 10 out of 10. So this, I think, for me, was actually the most compelling one because as a VP of software engineering, I'm looking at the effectiveness of the end-to-end system. I'm concerned about lead times and cycle times. The thing I do not want is rework. I don't want escape defects, but I also don't want rework. I want linear flow of work through my app dev machine, my modern software factory. So this to me was huge, huge, huge. And an easy win because it wasn't dependent on having to go and fully model out huge areas of functionality where, in my case, in the example I showed you, I did know what the functionality did, but in the vast majority of applications you have in your enterprises, you don't know what that functional spec even is supposed to be for some of these applications. So those are harder things to do. Huge value, but harder to do. This is huge value and very easy to do, and which is why I say it's the most compelling takeaway from the experiments that we did. Other things. I think the first 2 points I spoke to. The third one on here about, getting started with this is easy, but there are some significant learning curves around how to model, and especially if you're putting this in the hands of testers who have been manual testers, that's a bit of a challenge to get the skill set gap to be able to go from drawing that. If you remember the second example where we had like a very simple model was fine, but then to go to get in the extra level of nuance about order and precedence requires a sort of engineering type of skill set. And then you think about the role of an SDET or a software developer in test, or even developers is more suitable, because you need the way of thinking around problem solving that's typically in those sorts of skill sets. So that's a learning and a point. Overall, we took away that there's huge potential here for being able to get to fully automated test suite maintenance, because if you actually get down the point where all of the modeling, all of the automation logic is embedded in the model, then from a maintenance point of view, I don't have to figure out which tests do I need to go and change. All I do is amend the model, take my entire regression test scripts, throw them away, and regenerate them from the model every time there's a change. So that's very appealing. We found that to get there is difficult, because especially if you're testing at the level of individual protractor or selenium scripts, say send keys or press this button, navigate to this item and press this button, then there's quite a large debugging overhead that and friction that you have as you export that script. It doesn't work, you've got to figure out why, then you've got to reflect it back in the model. So we found that a little difficult. So we did some more experiments around that, and I think the way forward with that is going to be for us to invest in more of sort of an object layer over that, so we can abstract that up and code to a higher level API. So instead of calling go to this XPath and click this button, it's going to be calls along the level of log in. If you can abstract up to that, then you move the debugging burden out of the modeling tool and into IDEs where you're building those object models or other tools. See Alex here, and his tools spring to mind with that kind of a functionality. So we think there's a path here forward where we can get to the point where we will be able to do fully automated test coverage, but we felt that this was we didn't hit this one out of the park in the experiments we did just yet. A lot of learnings from that. The other quote on here was from one of our POs, product owners, a similar thing, just talking about the benefit to the discussions and the collaboration that the tool enabled among the team around requirements clarity. So summing up then, going back to the challenges and aspirations that I started the talk with, we felt pretty comfortable declaring victory around the acceptance testing new stories, that we clearly got to clear, complete, concise, unambiguous requirements. We clearly got to high confidence in the functional coverage, and we clearly got to fewer defects escaping the sprint and less rework downstream. So we're very, very happy with the results there. And on the strength of that, I've moved forward to roll this out and operationalize this across all of my teams for in-sprint development and acceptance testing. On the regression testing side, I think it's a bit more nuanced, and it depends a little bit about the conditions of what you're doing. I mean, the example we had, if you really, really know the functionality fully and it's small enough and componentized enough, if you've got good abstraction layer like test frameworks that may have been built in, I don't know, TestNG or something that gives you an interface you can code to, where the debugging logic stays in your IDE, and ARD is essentially just orchestrating that, then there's really some huge benefits to be had by going down this road, applying it to regression testing. If not, then it's harder, and it's a question of benefits and rewards and how much pain you're prepared to take for the gain. And obviously that's the learning out of that, as well as we evolve the ARD tool, is in trying to address that point of specifically about how we integrate better for automation. So that was it really. That was the takeaways.